Given quadrant 1 of the unit circle below, evaluate cosine of 5 pi over 3. So I know that because of everything I've done this past week, that cosine is, first off, it's the x value of my ordered pair. I also know that cosine of anything that's a pi over 3 or has a reference angle of 60 is going to be some iteration of 1/2, so plus or minus 1/2. So I'm thinking about where 5 pi over 3 is. I know that 6 pi over 3 is the same as 2 pi. So that means, so here's 6 pi over 3 right here. So 5 pi over 3 is pi over 3 or 60 degrees less than that, which means that this has to be lying in quadrant 4. Because it's in quadrant 4, my x's are positive, so I know that cosine of 5 pi over 3 equals positive 1/2. Unit circle for memory, I'm going to skip over this guy because there are several videos for you to watch. If you are struggling with that, check at the very bottom of Module 2 on this week, and there is a YouTube video that's great for you to go back and do that with. Evaluate the following trig functions. If we have cosine of 90 degrees, that means we're looking for the x value once we get to 90 degrees. When I look at 90 degrees, my x value is 0. So cosine, so here's 90, here's my x value. Cosine of 90 is going to be 0. Sine of 5 pi over 6, I'm going to go all the way to 5 pi over 6. I know that sine is going to be my y value, so that guy is going to be 1/2, positive. Tangent of 11 pi over 6, when I go to 11 pi over 6, I know that tangent is sine divided by cosine, so negative 1/2 divided by square root 3 over 2. Remember, we flip and multiply, so negative 1/2 times 2 over root 3 equals negative 1 over the square root of 3. Rationalize your denominator, and you should get negative square root 3 over 3. Cosecant of 5 pi over 6. We're going to 5 pi over 6 and checking out that value. Cosecant is the reciprocal of sine. So remember, you're taking that sine ratio of 1/2 and you're just flipping it over. So that's going to be 2 over 1 or 2. Moving on, convert the following to degrees if in radians or radians to degrees. So we need to remember our constants of proportionality. We need to know if we're going 2 degrees, we're multiplying by 180 and dividing by pi. If we're going 2 radians, we're multiplying by pi and dividing by 180. This first one right here says 3 pi over 4. So we're going 2 degrees. So we're multiplying by pi, dividing by 180. Let's color code some of this, so I just have a good reference point. So we're starting off with 3 pi over 4. Remember, we're multiplying by 180, dividing by pi. Those pi's cancel out. And I'm going to say 180 divided by 4, and I get 45. 45 times 3 is going to be 135. And we're in degrees because the pi's cancel out and left us with degrees. We're at 250 degrees for this next one. I'm going to go to radians. So I need my degrees to cancel out, which means degrees will go in the denominator. Pi goes in numerator. I get those degrees cancel. I'm going to take off those zeros, divide by 10 on each one. 25 and 18 share no GCFs, so I'm just going to leave this 25 pi over 18. Last but not least, we have 7 pi over 4, negative 7 pi over 4. Remember, multiplying by 180, dividing by pi. Pi's cancel. 180 divided by 4, again, 45. So we just have negative 7 times 45 degrees. And I get that this is negative 315 degrees. Box it, we are done. The terminal side of theta, an angle in standard position, intersects the unit circle at point P, negative 1/3, and negative square root of 8 over 3. What is the value of secant of theta? Okay, so I know secant is the reciprocal of cosine, or whatever my cosine value is. So cosine is my x value, so I know cosine of theta is negative 1 over 3. That means secant of theta is going to be negative 3 over 1. Or if I were to work this out and say 1 over negative 1 over 3, remember what that e looks like is 1 divided by negative 1/3. You flip and multiply, and we get the exact same thing, negative 3. If x is in quadrant 3 and sine of x is negative 1/2, what is tangent of x? Let's go up and look at my unit circle really quickly. I know that according to my unit circle in quadrant 3, when my sine value is negative 1/2, that happens at 210 degrees. And I also know that my ordered pair is going to be negative 1/2, and then that's going to be negative root 3 over 2. Tangent, remember, is sine divided by cosine. So tangent of 210 is going to be negative 1/2 divided by negative root 3 over 2. Flip and multiply. And we've done this enough times. I hope that you are just doing this automatically. Whoops, that is positive because they are both negative. So we are looking at positive root 3 over 3. And remember that tangent is positive in quadrant 3 because it is the ratio of two negative numbers. Number 7, the point M, t, 4/7 is located on the second quadrant of the unit circle. Determine the exact value of t. So let's get this done right here. I know if here's my unit circle, we're located on the second quadrant, 4/7, about 1/2, maybe a little bit less. Okay, so we know we're looking something like that point right there. I also know that 4/7 is not a value on my unit circle. So let's think about what we're doing here. I do know that 4/7 is the sine value. So I know that sine of theta is 4 over 7. Here's my theta. I also know that when I am looking at these guys, I also know here that it's asking me for t, which is going to be cosine of that value. I know that my cosine is going to be negative because it is in quadrant 2 and my x values are negative. I also know some things about trig ratios for sine, and I know that sine is opposite over hypotenuse. Now we don't have a triangle yet, but I can draw a triangle. And let's take this out, make it a little larger. And I know that if I have my triangle here, I don't even need to know what my reference angle is. I know that my opposite side length from this reference angle is going to be 4, and I know that my hypotenuse is going to be 7. We also know that this is a right triangle because I pulled it from right here, and this lays on the x-axis. So I want for us to look and do some Pythagorean theorem. So we know that if I also call this A, B, and C, I could say A squared plus B squared equals C squared. Plus 16 equals 49. A squared equals 33. And A is the square root of 33. So I'm going to call this side length, or this adjacent side length, the square root of 33. And that makes sense because it's not going to be quite as long as the hypotenuse, but it is going to be slightly longer than 4, a little bit more than 5, between 5 and 6. So I know that my cosine is adjacent over hypotenuse, so this is going to be negative square root of 33 over 7. And again, it is negative because I'm going to the left to get to that x value right here. So technically, that should be a negative square root 33 on that triangle, or t. Given point A, 1/2 square root 3 over 2 is on the unit circle and whose center is the origin. If theta is the angle created from starting at 1, 0 and terminating at point A, what is the value of sine? Guys, these are a lot of tricky words. It's literally telling us we have an angle. This angle terminates at 1/2 square root 3 over 2. We know that sine is our y value. So my y value is going to be root 3 over 2. What ordered pairs produce starting at 1, 0? Oh my gosh, look. And counterclockwise, so we're moving to the left of 60 degrees. Here is my theta, and I know my unit circle. If I look up here, this looks like it's going to come down to be about 1/2 on my x-axis, which means that my y value is square root 3 over 2. So I'm just going to write this down. And if I absolutely needed to, you could go up here and look at your unit circle and know that at 60 degrees, your ordered pair is 1/2 square root 3 over 2. On the unit circle shown in the diagram below, sketch an angle in standard position. Standard just means we start at 1, 0 and we move counterclockwise, whose degree measure is 240, and find the exact value of sine of 240. All right, so we know here we have 90, we have 180. 240 is 60 degrees more than 180. So let's get this sketched right here. I also know that this 240 degrees, this has a reference angle of 60. And I can also kind of use a little bit of common sense here. If I look at about where that lies, I see that that looks like my x value and my y value. So I know that this is 0, -1. It looks like my x value is going to be about halfway to positive or -1. And my y value is going to be almost all the way to -1. So if my x is halfway, it's -1/2. My y is negative root 3 over 2, because remember that's like -0.866. So I need sine. Remember, sine is my y value. So I'm going to say sine of 240 degrees equals negative square root 3 over 2. In the accompanying diagram unit circle, the ordered pair negative square root 3 over 2, comma 1, -1/2 represents a point where the terminal side intersects the unit circle. What is the measure of angle theta? Now we just did kind of like the corresponding, right? So the angle that we just did was 240, or the reference angle of 60. This guy, the ordered pairs are flipped, and my reference angle is 30. So 180 and 30. So we get 180 from going this first part. We know that 30 degrees reference angles share this ordered pair. So 180 plus 30 is 210 degrees. The other way we could check here is via calculator, and I'm going to show you guys that really quickly. So if I pull out my handy dandy calculator, we can say here, and remember you guys all have access to this on your desktop, I'm looking for a measure of angle in degrees, so let's just make sure that we are in that degree mode. That degree is highlighted. Let's quit out of there. Now I want to say I need to figure out what is, if I know that cosine is negative square root 3 over 2, I can figure out my sine value. So I'm going to go here and do second cosine. We did this, you guys did this in Math 2H last year to find that measure of the angle. I'm going to click on alpha y equals, so it gives me that stacked fraction. It just keeps me more organized. And I'm just doing negative square root 3 over 2. And when I press enter, I get 150 degrees. Now, the reason that this will not give me, let's try sine really quick. So the reasons that neither one of these give me the correct angle is because this gives me these values. There are two negative cosines, so if I look at my unit circle, I know that there are two places where the cosine is negative square root 3 over 2. It happens in quadrant 2 and in quadrant 3. In sine, there are two places where it equals negative 1/2, quadrant 3 and quadrant 4. It's always going to give me the smallest angle possible that it can give, but I can start using some of what I know, and I know that if the inverse, so that angle, that cosine can be 150 or it can be negative 30. The one that has to exist if we're asking for the terminal side and we both have negative sine and negative cosine, I know that 210 also shares the same reference angle as both 150 and negative 30, and 210 lies in quadrant 3, which meets both of these demands, that both my x and y are negative. So we have to be in quadrant 3, and the only way that works is for 210. In the diagram to the left, the length of which line segment is equal to the exact value of sine of theta. So we have a few line segments going on. We have OS, we have ST, we have SR, OR, and I guess technically TR. So we need exact value of sine. I know that sine of theta is opposite over hypotenuse, and in this case, my opposite side length is ST or TS. And my hypotenuse is OT. I also know that because this is a unit circle and it gives me that value right there, that my radius is 1, which means that OT equals 1. So if OT is 1, then we just have ST divided by 1, which is just going to be ST or TS. As theta increases from pi to 3 pi over 2, let's get that graphed. Here's pi, here's 3 pi over 2. Which statement is true? All right, we're talking about sine and cosine values. Let's get some ordered pairs. I know at pi, I'm looking at negative 1, 0. At 3 pi over 2, I'm looking at 0, negative 1. Let's also get some color coding. My sine values, or my y values, are going from 0 to negative 1. My cosine values are going from negative 1 to 0. So let's get that written out. Cosine of theta, negative 1 to 0. Sine of theta goes from 0 to negative 1. So this says sine increases from negative 1 to 0. No, our sine values are decreasing, right, because we're going down. Let's see. Sine decreases from 1 to 0. Well, it should say negative 1 to 0, so nope. Going from 1 to 0 is decreasing, but going from 1 to 0 would only happen if we were going from pi over 2 to pi. Cosine decreases from 0 to negative 1. Nope, that would also happen going from pi over 2 to pi. Cosine increases from negative 1 to 0. Let's see, negative 1 to 0, that is what's happening, and we're going to the right. Yes, that checks our boxes. If theta is an angle in standard position and its terminal side passes through the point negative 1/2 square root 3 over 2, then a possible value of theta is, all right, x is negative, y is positive. Guys, this is going to be in quadrant 2. So we know we need to be between 90 to 180 degrees. So let's get rid of A and D. I also know, let's draw this out. Our x value is 1/2, and my y value is square root 3 over 2, so it's up here. That when I start off with that 1/2, that means that reference angle is going to be 60 degrees, and the guy that has the reference angle of 60 is going to be 120. The angle theta is in quadrant 4, and cosine of theta is square root 3 over 2. What is the measure of theta? Same thing, guys. If y'all are memorizing these, this is where it is best. So cosine is square root 3 over 2. That means if I'm looking at my unit circle, I'm going to be wow, that was just a beautiful circle. I'm going to be closest to that 1. So remember, if we have square root 3 over 2, 1/2, That means that our reference angle is 30 degrees, and I remember that because I write that 3 first. Square root 330. So I know that if my reference angle is 30, my standard angle is going to be 330 degrees because we're 30 degrees less than 360. Given the same angle theta as in 14, what is the measure of the cosecant? Great. I know that cosecant, CSC, is going to be 1 over the sine of theta. And I know that sine of theta is going to be, negative 1/2. I forgot that negative sign earlier. So if I know if I have 1 divided by negative 1/2, then that's just going to be 1 divided by negative 1/2. My cosecant of theta is going to be negative 2. Or we can say cosecant of 330 degrees is negative 2. Use special right triangles to find the coordinates of the point of intersection of the angle 45 degrees and the unit circle. Guys, we are almost there. Let's get that done. 45 degrees. I know that 45 degrees is going to be here. Oh boy. Draw on my circle. Okay, that actually didn't end up as terribly as I thought. So here is the point of intersection a 45-degree angle makes. So you're just swinging that radius up until we get to 45 degrees. Now, if I were to draw my triangle, let's do this in blue. I drop that down to the x-axis for my right angle, and I'm actually going to pull this guy out so I can see him a little bit better. We know these are equal angles. This is 90 degrees. I also know that my hypotenuse is 1. Now, we did this on I guess like a week and a half ago when we talked about how do I transform the things I already know. When you did 45, 45, 90 triangles way back in like Math 2, we remembered, okay, I know that 45, 45 are x square roots of 2, x and x. So now that I know that this x square roots of 2 value is going to be 1, I can solve for those side lengths. Rationalize my denominator, and I get root 2 over 2, which means that both of these sides are root 2 over 2, root 2 over 2. Now I also know that for my coordinates, so here I'm going root 2 over 2 right, root 2 over 2 up, and because that's asking where does it correspond, we have root 2 over 2 and root 2 over 2. Because that means we went square root of 2 to the right, that's that cosine value, square root of 2 up, that's that sine value. Last but not least, use special right triangles to find the coordinates of the point of intersection of 210 and the unit circle. We get to see my lovely drawing skills one more time. Honestly, again, it's not the end of the world. Okay, 210. We know that that's between 180 and 270, and 210 is only 30 degrees more than 180. We do not have a triangle with 210, however, so we come up here and we make that reference triangle with the x-axis. That reference angle is 30 degrees because it's 30 degrees more than 180. So let's actually pull this triangle out. There's my right angle, and I know that if that's 90 and that's 30, we have 60 degrees right here. The other truth that I have is that I know that my hypotenuse is 1 because my hypotenuse is literally just my radius being swung around to create that 210 degree angle. I also know that my 30, 60, 90 triangles, the ratio that we learned way back in the day, is going to be x, 2x, and x squared roots of 3. Now if I know that 2x has to be equivalent to 1, I get that x equals 1/2, or my short side across from my 30 degree angle is 1/2. I also know that if x is 1/2 and my long side across from 60 degrees is x times the square root of 3, 1/2 times the square root of 3 gives me square root of 3 over 2. But I also know that because both of these are in quadrant 3, what we're really doing here is we are going square root 3 over 2 to the left, right? Because we're having to get to this point on the x-axis, which is to the left of 0. So my x value is negative root 3 over 2. And we're going down 1/2, so my y value is negative 1/2. And we are good to go.